Oh, myself, Soham Nimale. I was given the task to implement this research paper in Python. And before I explain the implementation part, I would like to go through the paper once. So, the first part of the paper is just the introduction to the algorithms and the related one. Yeah. So, the implementation starts from here, where this algorithm I have implemented it in Python. Also, I have done some optimization in it. Then I have implemented the dimension reduction, where the output of this algorithm are the representative rows from the data set. And we need to reduce the dimension of them into, say, two dimensions so that it is easily visible. It is easy to visualize for the data scientist. And yeah. This is pretty much the important part of this algorithm. Now I will switch to implementation part. Yeah. So this is the implementation. I have done it in Google Colab file. Uh, the link to the same is uploaded on my drive, as well as I have submitted a zip folder in which I have kept the downloaded file. So before I start with the implementation, these were a few issues in the paper which I tried my best to solve. First is that the MNN score that we saw in the algorithm was calculated after every iteration for the entire data set. The this was a bit unnecessary because it increased the time complexity because due to the calculation for entire data set, whereas only a few part of it was utilized. So I optimized this function. uh, yeah, then there was a error in the algorithm itself that uh, the train sample used to be union with x of index, whereas it should have been x of train index. So this part was also corrected. Then the until loop logic was also a bit off because in the research paper, this was the logic, but according to what was written in the text of the research paper, this is supposed to be the correct logic. And it also makes sense because cardinality of, the length of the data set or number of rows, if they are less than k, then we should stop the algorithm rather than the trained sample. So I will start with the, no, sorry, this is the last error. Yeah, the value of TMS were not clearly mentioned in the paper. So I assume it to be some default value. So yeah, it can be changed as per the user's need. So starting with the implementation, these are the libraries that I have utilized in this implementation. Then let us begin with the functions. So first function is get NN score function. This has been customized to be able to give NN scores for both static and dynamic versions, as it has been mentioned in the research paper. It is pretty clear if we read the function. It basically gives us the in degree of vertices, which is equal to the NN score. It has a time complexity of n square. So yeah. Then we have the get max occurrence indices function. This is also a bit customized because this function is very simple. It basically gives the indices of the maximum element in a list where repetition is allowed. But the only customization is it will ignore -1 because in dynamic or static KNN graphs, I replace the elements with -1 sometimes. So it is useful for those cases. Then we have get max MNN score indices. I have utilized this function as mentioned before. It is a bit custom version as well because rather than calculating MNN score for the entire data set as proposed in the paper, we calculate only for the ones needed, like the indices that are needed. So it is a bit optimized. Then we have the get row indices. These are all util functions. This is a util function. This is a util function. This as well is a util function. So it can be understood after reading them. There is no need to like implement it because I have used them as a util function. This is the important function. Uh, Basically, the algorithm we just saw in the research paper, it has been written in this function. It takes input as a data set. uh, it takes the KNN value by default, sorry, K value for KNN. By default, it is 5. Then it takes dynamic sampling as true or false. In the research paper, we have been asked to implement it in dynamic or static, depending on user's needs. That's why we need this variable. Then we have algorithm as auto, which is needed for KNN, drawing the KNN graph. Then we have the TMS values. These are, as I mentioned above, that in the research paper, it is not clear that what value they have used. So I have taken a value by default, but as per user's need, they can change it. Let us now take a look at the algorithm in short, how it works. First, we make a copy of data frame because we don't want to delete the rows in the dataset itself. Then we find out the KNN graph. We initialize the train samples with null, where there are no rows in this. There are only column names. So this KNN graph is then uh, converted into proper format like KNN adjacency matrix. This is the main graph, and these are the distances. Then this is the main while loop, the repeat until loop that we just saw in the research paper. The basic working of this is it will work until two conditions are met, as seen in the research paper. First, it will calculate the NN score. If NN score of all the elements are zeros, then it will break. Otherwise, um, it will basically check if there are. It will get the maximum, the indices of maximum NN scores in the data frame. If there is only one index, then it will directly append it into the train index. This plus symbol is union. And if there are more than one NN, highest NN scores, then it will further find out the maximum MNN scores as per the algorithm. So this is the basic implementation where we add the indices into our train indice. Then we concatenate the data frame rows. Uh, yeah, then we drop the rows in the data set that we just took. It is all as per the algorithm, and I have also commented so it is easy to understand. Then this is the part where we depending on if it is a dynamic KNN graph or static KNN graph, we decide to change or not change the graph. Uh, Finally, if there are any rows left, uh, we again try to select representatives of those remaining rows and then return the train samples. This is completely as per the research paper. Then we have the get embeddings function, BHTNSE. This is also an algorithm that is used in the research paper. It is used to convert higher dimensions into two dimension or three dimension. The dimension can be changed as per user's need, but it is preferred to be two dimension. Uh, this is the results. First, we have the data set, MNIST data set. We get the data set into X and Y. Y are the label and X are the data, like the pixel values. So this is the example. Then for now, let us ignore the data set 2. We have not used it. Uh, the major step to take here is add an index column called as IDX into the X dataset, not the Y dataset, only the X dataset. This has to be done before calling the uh, KNN sampling function. So when we call KNN sampling function with dataset KNN value of neighbors or dynamic sampling, we get these exceptions because these exceptions occur in the try and catch block during the static KNN graphs. It is unavoidable. That's why I have just printed it. After that, again we try and accept like to error handling for deleting the index column because it is no longer needed. We have successfully uh, served the purpose of this column. The main purpose of this column is after we have selected the representatives, we need to know the index of the representatives in the original data set. And in order to do that, we need a column called as index. So this is compulsory to implement. Otherwise, we won't be able to get the index in the original data set. Then, yeah, this is the output train samples. These are the representatives. Um, then we have the dimension reduction. We use the function that I just told with the train samples. N components means two-dimensional. How many dimensions? Uh, Initialize solution is random. In paper, it is mentioned. We can also use PCA. Then we have random state and perplexity. These are the results for the same. Now talking about the final results that we get from plotting the graph. To get the final results, we need the train sample embeddings and the train samples indices. The indices were calculated over uh, year before dropping the indices from index column from the train samples. So once we have the train sample indices, we get the label for each train sample index. Then we print the labels. These are from 0 to 9. Then as we can see over here, then we simply draw a scatter plot where for each label we have one color and that color has been plotted over here along with the label. So that is pretty much it. This is the final result of the algorithm. I have also written code for scatter plot with k-means clustering for those data scientists who want to identify the patterns uh, in the graphs, reduce dimensional graphs. So this is the implementation of k-means clustering, and as you can see, the results are pretty good for both of them. This is also good as well. This is also good. So yeah, this completes the implementation. I will repeat one important thing again that this index column that we had added uh, over here. This is very important. If we forget this, then the code will give error. So yeah, that is it. I will upload this code along with all the other result files and any dependencies in the Google Drive as well as zip folder. Thank you.